Hi,
Good
Samani.
afternoon, all. I'd like to welcome you. Yes, thank you, Mr. Hassan. I'd like to welcome you all to our today lesson. It's about the atom. By the end of this lesson, you should be able to recognize and define the concept of an atom. You should be also able to uh, recognize the atomic energy levels, as well as the atomic number of an atom, the atomic mass of the atom, and you should be able to differentiate between the subparticles like electrons, protons, and neutrons in terms of mass and charge. Also, you should be able to draw the figure of the electronic configuration of an atom. So, if you can do any one of these objectives by the end of this lesson, please do ask. Before I start our lesson of today, I'd like to ask, let's say, Mr. Ahmed, do you know what's the smallest unit of the living organism as you studied before in biology? The cell is the smallest unit. Your voice is not clear, by the way. The cell is the smallest unit in the living organism. The same way in here in matter, as you know, everything around us is mainly matter, and matter is anything that takes a space and it has a mass. This is a reminder of what we had before. This matter, its smallest unit is the atom. To understand this, I'd like you to imagine the building you're living in. It's mainly consisting of walls, and then the walls is consisting of bricks. Now, are the bricks the smallest unit in the building, Mr. Hassan? Do you think the brick is the smallest unit of the building?
Yes, it is the smallest
Actually, with all my
unit
respect to
in the
your
building.
answer, okay, well, with all my respect to your answer, however, it's not the smallest unit of the building. The smallest unit, even, you can break down the brick into very small particles as if you're crashing it. So when you crash it, it turns to... So, Mr. Hassan, if you crash the brick, what would you find out?
Some dust and small particles like
Very
sand or
good.
something.
So you'll find very small very good. You'll find very small particles. These are the sand particles. Even though there is each particle of these, each sand particle consists of smaller unit, and this is what we call the atom. So let's move to the second slide. So as you learned here, the cell is the smallest unit in a living organism. However, the atom is the smallest unit in matter. Do you have any question till this point? Any question? What? Yes, Ahmed. Oh. As I said, every substance is made up of atoms. Example, the water that we drink, it mainly consists of two atoms, two of hydrogen and one of oxygen. Another example, the air we're breathing is containing oxygen. The oxygen mainly consists of two atoms of oxygens. When we go through later on, you'll know each substance, it consists of how many atoms, but our main lesson today is to know the deeper or the structure inside the atom. This makes us go back to the cell, which is the unit of living organism. So, who knows, Muhanna? Do you know the cell? Does it only consist of this cell, or is smaller even than that? There are subparticles inside it. Mohammed,
There is subparticles inside it. Like there is subparticles
do you know what
inside
are
it
these
that
subparticles?
contains
What's the main particle inside the cell? I'm sorry, I can't hear you well.
the electron.
The? No, I'm asking about the living organism cell. What's the main sub? No, I'm asking about the cell in the living organism. Well, let's see, Mr. Yaoud.
The nucleus.
Yes. So the nucleus is the main subparticle in the cell. The same way here in the atom, the nucleus is the main part of the atom. This nucleus consists of protons and neutrons. Around the nucleus, we have electrons are revolving all around in orbitals, okay, or in orbits. I need you to imagine this atom as the solar system. Who knows the solar system? Who knows the solar system? It's the sun, the planets. Okay, good. So, Mr. Hassan, what do you know about the solar system? And the planets revolving around it. That's so good. That's so good. Excellent. So the same way in here, but it's really small in size. The atom has the protons and neutrons at the middle or at the center of it. And the electrons are like the planets. They are revolving around the nucleus in certain orbits. Now, it's really important to know the position and the mass and the charge as well of these subparticles. The electrons, as we said, they are found in the shells, like each energy level is known as shell or energy level. And the protons and neutrons, they are found inside the nucleus. Now let's have a look at the mass. Are you able to see the mass in here? Now, who can tell me what's the mass of the nucleus, of the proton from the table in here? What's the mass of the proton? Yes, Mohammed?
1.
Very good. And what about the neutron, Mr. Yaout? It's also 1. Very good. However, Mr. Ahmed, can you have a look on the mass of an electron? If you divided 1 over, let's say, 2,000, would this be a measurable number, like you consider it a huge number, or a very small number that we can say is 0? Mr. Hassan? If we divided 1 divided 2,000, you can do it even on your calculator. It's very small. It's almost, you can say 0. You can say 0 because still it has a mass. But compared to proton and neutron, you'll find out that the electron is so small that we say it has no effect on the mass of the atom. So the mass of the atom is mainly at the center of it. The mass of the atom is represented by the number of protons and neutrons inside it. We'll clarify this more in the second slide. However, I need you to have a look at the charge. The charge of an electron is negative. Of the proton, it is positive, and the neutron, we say it has 0 charge, meaning it has no charge. So, to understand more, let's move to the second slide, or to the next slide. In here, relatively, an electron has almost no mass compared to proton and to neutron. And again, that's why the mass of an atom is mainly in its nucleus. Before I move to the next point, is there any point unclear in here? Is it all clear? Thank you. Here is the atomic structure. In here, as you see, the red circles are the protons. Here are these red circles are the protons. Now, excuse me, the black ones, these black ones are the neutrons, and the very tiny small ones are the electrons. As you see, each electron has its own orbit the same way in a planet. Now, Okay. I'd like to go back to this one. Let me see in here. Sorry. As you notice in here, there are 2 electrons in the first energy level in here. I'll mark it with this point, with a star. Look all at this first energy level. In here, as you see, you have only 2 electrons. And the third electron is on the second energy level. My question in here, why is that this third electron is not on the first energy level? Like if I have 3 electrons, why don't we put them all on this first energy level that I've marked it with a star? This is because each energy level has a specific number of electrons it's able to carry. This makes us, move to now, as you see in here, electrons are arranged in energy levels. Sometimes they are known as energy shells around the nucleus of the atom. Each level can hold a certain number of electrons according to the rule that says the maximum number of electrons is 2 equals to 2n to the power 2. N is the energy level number. Now let's try it and let's see how we do it. In here, for example, I'll write down the rule. Now let's see. The rule says that the number of electrons equals 2n to the power 2. As we said, n is the energy level 1 number. So let's see energy level number 1. It's able to carry 2 times. Now, Mr. Yaoud, can you tell me n in here? What number should I write down instead of n? As long we're talking about the first energy level?
I think 1.
Very good. So very good. As long we are talking about energy level 1, so instead of writing n, we'll write 1 to the power 2. Now let's do our math. It says here 2 times 1 to the power 2. All of us know it's 2. So 1 to the power 2, it's only 1. So 2 times 1, I need to erase this. I'm not bad in math, I just did it wrong. So in here, 1 to the power 2 is 1. So 2 times 1 is it's 2 electrons. This means that the first energy level is able to carry only 2 electrons. It could carry less, but not more than 2. So let's get back to our slide. Here you go. So as you see in the first energy level, which is energy level number 1, only 2 electrons in this energy level. Now, who can do the energy level number 2? Okay, Mr. Ahmed, can you do it?
Yes, again?
I need now to know the energy level number 2 is able to carry up to how many electrons? The maximum it's able to carry. What's the rule first? Do you remember? We said that the number of electrons equals
2 multiplying 2 power 2.
Very good. So it's gonna, as long as we're talking about the energy level number 2, so it's 2 times 2 to the power 2. So this is equal to 2 times 4 equals 2 times 4 is 8. This tells me that the second energy level is able to carry up to 8 electrons. So it could carry 1, 2, 3 till 8, but not more than 8. Now, Mr. Hassan, can you do energy level number 3?
Uh, 2 times 9.
Can you write it down? 2, so it's going to be, let's do it step by step. It's 2 times 3 to the power 2 equals 2 times 9, this is equal to 18. So this means that the third energy level is able to carry up to 18 electrons. And when I say up to 18 electrons, it means 18 or less, but not more than that. So this is what we actually have done. As you see, the first energy level is having 2 electrons, and the second energy level is able to carry 18. The third energy level is able to carry, 18. The second is able to carry only 8. However, if we look at the figure in here, as in method of stability, though the energy level 3 is able to carry up to 18 electrons, it prefers to have only 8 electrons. This is maintain certain stability. The word stability means it has too much energy, like it's better for the atom if its energy level number 3 is carrying only 8. So when you do the electronic configuration, this is how you actually do it. You put in the first energy level 2, because to understand this, I'd like to write the example here on the left. It says that calcium, Okay. Now, calcium in here, it has 20 electrons. We'll understand this in more details later. So if I'm trying to distribute these 20 electrons, this is how we do it. In the first energy level, Mr. Yaoud, how many electrons we said it's able to carry? If you don't remember, you can do the calculations. 2, very good. So as you see here, we have 1 and 2 electrons. Very good. Now, so as on the second energy level, it's 8. So 2 and 8, these are 10. We have still 10 electrons to be distributed. So shall we put the whole 10, Mr. Ahmed, shall we put the whole 10 on the third energy level? It's able to carry 18. Can we put the whole 10 to complete the 20? No. Can you tell me why no? What the rule says in here? Let's get back to the rule. Though third energy is able to carry up to 18 electrons, it prefers to carry how many? Mr. Ahmed, it prefers, very good. It prefers to carry 8. Good. So in that case, I still have 10, yes, but I can't put the whole 10. The atom will not be stable. So I put 8 at the third energy level, and whatever is left, like the left 2 electrons, I put them on the fourth. To understand this, let's do another example in here. I have, for example, potassium, its symbol is K, and it has 19 electrons. This is how I do the electronic configuration. The first energy level, I only put 2 electrons. This is 1 and 2. Now, let's see. The second energy level, Mr. Yaoud. Can you tell me how many electrons should I put?
8.
Very good. However, we still have how many to put? Okay, so let's first put the 8. 1 second. So 1, 2, 3, 4, 5, 6, 7, 8. Now let's go to the third. So we have here, let's write it as 5, 2, and 8. These are equal to 10. So we still have 10 electrons to put. So let's draw the third energy level. Now, 1 second. So this is the third energy level. Mr. Ahmed, how many should I put in here? I still have 9 to go to have 19. To have 19 electrons, I still have 9. We've put only 10. Now, how many left? to put on the third?
third shell we can carry 8.
Okay, how many we should put? How many left to put? No, we already have 10, right? We've already put 10, so how many left from the 19?
10.
10. Shall I put the whole 10 on the third energy level?
No, we cannot.
Very good. How many should I put?
8.
8. So I shall put 1, 2, 3, 4, 5, 6, 7, and 8. Now, let's get back to Mr. Yaout. I'm sorry I'm not asking Muhammad because Muhammad knows this. So, Mr. Yaout, why did Ahmed, allow me to say Ahmed, why did Ahmed put only 8, not 9?
In order to make the electrons more stable, or the atom more stable.
The whole, very good, to make sure that the atom is stable, the energy level prefers to carry only 8. So now I have in here 10 at the first and the second, plus the 8 at the third energy level. So now we have a total of 18. Oh my God, I still have 1 electron. Where should I put it? Shall I put it on the same energy level, the third, Mr. Ahmed? I still have 1 to put. In here, I have only 18. I have 1 more electron. Where should I put it? Should I put it on the third, or it's better to go to the fourth and put it there? Very good. So in that case, excellent. In that case, I put whatever is left from 1 to 2 extras, I put them on the fourth. This is what you should do, or what you should know at this level. Till this point, do you have any problem? Okay, you can put right or no. Do you have any problem? So the electronic configuration of sodium is mainly, this is the symbol of sodium, it's M, A, and it has 11 electrons. So, Mr. Yaout, can you draw the electronic configuration?
Okay.
Okay. I'll make it easier for you. Very good. Okay. Very good. So first energy level is 2. Very good. So, excellent. You've done it great. Okay. Now, so this is excellent. So now you get this point. Now let's move to the second part. This is the helium atom. It's just a configuration to let you know. Here you have protons carrying positive charge, as we said. Neutrons in here, they have no charge, and the electrons, actually they should be much smaller than this side, but it's okay for now. They're carrying negative charge. Now I need the three of you to look at the figure and tell me, what do you notice between the number of protons and the number of electrons? Look at the figure and tell me, what do you notice on the number of electrons? Excellent. But Mr. Yaout, I'm sorry, you have to raise your hand. Thank you. So, as you see in here, Mohammed, what did you notice? Yes? Go ahead,
They are
Mohammed.
the same. They are the
Excellent.
same.
So the number of electrons is equal, very good, ya Mohammed. The number of electrons is equal to the number of protons. By accident, the number of neutrons as well is equal. However, it doesn't happen in all atoms. But in every atom, the number of protons is equal to the number of electrons. Tayyib, this is a really important question, and I'd like to ask it to Mr. Ahmed. Now, the charge of the atom itself, taking in consideration the number of protons and the number of electrons, the total charge of an atom, is it positive or negative or neutral?
neutral.
Excellent. Very good. It's so simple. Let's do it this way. I have in here 2 positive protons plus 2 negative electrons. So the total charge of an atom is 0. So the atom is neutral in charge. To this point, do you have any difficulties? So as you see here, this is the electronic configuration of the sodium. We've done it before. Here, it's the first energy level is able to carry, we put only 2 electrons. The second is 8. Then we have 1, 2, 8 is 10, and 1 is 11. There is something really important you have to understand. We call, if I write down the number, the symbol is written in here actually. This number, the small number, we call it the atomic number, which is 11. It represents the number of protons. And this one is the mass number, the bigger number, which is 23. It represents the number of protons and nutrients together. So, based on this, if we calculate these 2 numbers, protons and the number of nutrients together, 11 plus 12 is 23. This represents the mass number. And this is what we said before, that the mass of an atom is at the center, it's at the nucleus, because it contains the protons and the nutrients together. Here, use the copy of the periodic table to write out the atomic number and the mass number. Before doing so, I need to set an example in here. If I've written to you like this, F, which is fluorine, 9, 19. I need you to tell me what's the atomic mass number and what's the atomic number only, and the number of protons, the number of electrons, and the number of nutrients. So the first one in here, not to confuse you, I'll write it down. It is the atomic mass number. In here, it is only the atomic number. Now, who would like to solve this? Mohammed, you know it, with all my respect. I need others, please. Try, I'll help you out. It's so good to make mistakes. This is how we learn. Anyone else? Any volunteers? Mr. Yaout, would you like to try? Okay. Now, we said the atomic number, is it the smaller or the bigger number?
It is a bigger number.
No. To know this, we say the mass number means it's the huge, the big number, which contains both protons and neutrons. So which one in here is the mass number?
It's the bigger one.
The bigger one. Very good. So the atomic mass number is 19. And
19.
This big number, we said, it's very good. It's mainly consisting of the number of protons and the number of neutrons together, right? Now, what about the atomic number? It's so small, so it's the smaller number. So the atomic number is 9. Now, who can tell me in this example, what's the number of protons? Yes, Mr. Hassan. Mr. Hassan, go ahead.
We will subtract the atomic
No,
mass.
I need the protons. No, sir, I need the proton number.
10.
No, sir, the proton
10?
number, okay, it seems this point is not clear, so let's get back again. This will make it easier. Look at here all. In here, the smaller number, as you see, which is 2 in here, is the atomic number. It's also the number of protons. However, the bigger number is the atomic mass number, and it's equal to the number of protons and the number of neutrons. So I'll do it aside in here. When I write down, I try to analyze this helium. I say that helium has atomic mass number equals the protons plus the neutrons. So what's the atomic mass number in here from the figure you see? Who can help me out? Where is the atomic mass number? Yes, Mr. Hassan?
4.
It's 4. Very good. Equals, where is the proton number? The proton number is the atomic number. So how many protons does this element have? Mr. Hassan?
2.
2. Excellent. Now, Mr. Ahmed, can we figure out how many neutrons? How do you get the nutrient numbers? Simple math. The neutrons equals, very good, the number of atomic mass number minus the proton number, which is equal to 2. Easy? Is it easy?
Yes, it's easy.
Very good. Very good. Shall we try another example? Okay. Now I need you to write down these examples. The potassium is 19. I'll make it easier for you right now because we won't have the periodic table. I'll write down the proton number of each. So this is here, it's 19. Sorry, yes, and here is 39. So potassium is 19, 39. Who can figure out the atomic mass number? Now you know that A is atomic, M is mass number, and the atomic number, as well as the number of protons, the number of electrons, and the number of nutrients. Now, who can do these? For potassium, it's 1939. Any volunteers? Mr. Yaoud, can you do it?
Atomic mass is 39.
This is 19 and 39. We said the atomic mass number is the bigger number. So I have 19 and 39.
39.
So which one is very good? So the atomic mass number is the 39. Now we said the atomic number is the smaller number. So what's the atomic number, Mr. Yaoud, for potassium?
19.
Very good. And we said this atomic number, Mr. Ahmed, is equal to the number of A in the atom of what? We said the atomic number is equal to what subparticles in the atom? Is it the protons or the neutrons or the electrons? No, we said it's equal to the proton number. So the proton number is as well 19. And from the example of helium, we know that the number of electrons is equal to the protons. It's also 19. Who can figure out the number of neutrons? Who remembers? How do we get the number of neutrons? It's written in here. It's so obvious. The number of neutrons is the mass number minus the atomic number. So it's merely 19 minus, 39 minus 19. So the number of neutrons is 20 neutrons. Now, who can do the second example? I don't mind making mistakes. This is how we learn, as I said. Please try. Well, let's try Mohammed. Calcium. Mohammed, calcium, it is 2040. So, Mohammed, can you tell me what is the atomic mass number of calcium?
It's 40.
Very good. Mr. Hassan, how did Mohammed know that 40 is the mass number?
Because it's obvious here, it's 40.
Yes, how did he know it's the 40? Why not the 20? I can write it this way. I can write some periodic tables, write it this way.
Because it is the bigger one.
Excellent. So because it's the bigger one, so the mass number is 40 because it's the bigger one. Now, Hassan, Ahmed, can you tell me what's the atomic number of calcium? Very good. It's the smaller number. It's 20. And it's equal to the number of A. Mr. Hassan.
Proton.
The atomic number is very good. So it's also equal to the number of proton. And the number of protons in any neutral atom is equal to the number of electrons. So this 20 represents the atomic number, the proton number. However, I would never prefer to say it's also the electrons, because sometimes you'll understand this later when an atom does a reaction. So in here, the number of electrons changes. So please, whenever I ask about the atomic number, you say it's the number of protons found in the atom. Is this point clear? The atomic number is the proton number. Please do not say it's the electron number, because the electron numbers change when the atom does a reaction. Very good. So now let's move back to our slide. So, I have another one in here. I need volunteer. Argon. Or let's see, carbon. 612. I write it aside here. Carbon. 612. I need one to do it totally by himself. Who volunteers, Mr. Ahmed? Can you do it? Okay, go ahead. 12 is what? Very good. 12 is the atomic mass number. Excellent. Then, what's the atomic number? Very good. 6 is the atomic number. And it's equal to the number of E. It represents the number of E as well as the atomic number we said.
Neutron and
No,
proton.
atomic number we said. This is the mass number. This one is proton plus neutrons. However, the atomic number is only the protons. Okay, very good. Now, based on this, can you tell me how many electrons are here in this carbon? We said that electrons are equal to the number of, and that's why the
Proton
atom
and
is
the neutron.
No, sir. The number of electrons. Why the atom is neutral, Ahmed?
The number of neutron is equal the number of proton.
So you said it. So the number of electrons, as you said, it's equal to the number of protons, which is equal to 6 as well. And that's why the whole atom is neutral. So you never make mistake in this one, right?
All right.
Perfect. Based on this, can you tell me what's the number the number of neutrons in here? I'll write it down again, sorry. In here I have carbon 612. As you said, the atomic mass number equals 12 and the atomic number equals 6. The number of protons is 6 as well. The number of electrons is 6. We're so lucky. Can you calculate, Mr. Hassan? Can you calculate the number of nutrients? From the rule you have in here? Very good. It's
Yes,
12 minus 6 is equals 6 electrons. We're lucky in here that protons, neutrons, and electrons are equal, but this doesn't happen in all atoms. Till this point, do you have any question? Let's see the carbon. This is the smaller number, so it's 6 is the proton number or the atomic number. The 12 down here is the mass number. Sometimes, by the way, the mass number is known as the nucleon number because it's the number represents the nucleus. So we call protons and neutrons, we call them the nucleons, and the mass number, we also call it the nucleon number. So summary, the atomic number of an atom equals the number of the protons in the nucleus. The atomic mass number, it is the number of protons plus the number of neutrons together, and it's known as nucleon number. The number of protons is equal to the number of electrons, and that's why an atom is neutral in charge. The electrons, they are orbiting in the nucleus, around the nucleus actually, in shells. Each shell can carry a set of electrons. Who can remember the rule we said about this part? Who can say the rule of the number of electrons carried in one energy level? I need others than Muhammad. What was the rule? We said the number of electrons in each energy level. Yes, Mr. Yaoud, equals. Say the rule first.
2 times
2 times, yes. Excellent. 2n power 2. Mr. Ahmed, do you remember this n? What was this n?
the number of the cell.
Very good. The energy level number, it could be energy level 1, 2, 3, and so on. Now let's go to the questions. Before we move to the questions, do you have any questions? Is there any point unclear? Mr. Hassan? Before we go through the questions, do you have yourself a question?
No, thank you.
Very good. Now, I need you to try, Mr. Hassan, now, the first element, which is oxygen. It's unclear in here, but I'll give you the numbers. So oxygen is 816. Can you do as we've done before, the atomic number? You can write abbreviations. So the oxygen, I'll write it down in here. It's 816. Can you do whatever we've done before, like writing down the atomic number, mass number, and so on? And draw the configuration as well, please. Shall we move to the white page? Would you prefer to move to the white page, Mr. Hassan?
Okay, no problem.
Okay, there we go. So, Mr. Hassan, you're going to do the first one. You'll be doing the oxygen. You know what? It's easier to do the electronic configuration in numbers. Don't draw. It's 16, for example. I'll do it here aside. I say that sodium. This is how we do it. It carries 2 in the first level, 8 in the second, 1 in the third. So do it this way. It's going to be easy. Okay? So I'll write down oxygen. 16. Okay, Mr. Hassan, go ahead. First, I need the mass number. Oh, you're doing the configuration. Fine.
Okay. We have here 4.
Very good, because we have 6 protons, so as well 6 electrons, so this is the electronic configuration, 2 in the first energy level and 4 in the second energy level. Very good. And what's the mass number of oxygen? Atomic mass number. Okay. I wouldn't say anything to the end.
Is it right?
Well. Now it's right, because we said the number of electrons is equal to the number of protons. Huh? Very good. We're missing something. There's a subparticle missing. You've had protons, electrons, there's a missing subparticle. What's the third subparticle?
Neutrons.
Mr. Ahmed, can you help him? Very good. So what's the number of neutrons in here? Excellent. However, I've done something really wrong. I started with me. It's my mistake. I'm sorry. The oxygen, I've just noticed. The oxygen, it's not. I'm sorry about this mistake. The oxygen is 816. I'm sorry about that. Forgive me. So you've been correct based on the information I gave you. However, the atomic number is 8. It's my fault. I'm sorry. I've written it first as 8. And the proton number is 8. It's not your mistake. The electrons is 8. Now 16 minus 8. So you have 8 neutrons as well. I'm sorry, this one was my fault, not yours. But you've done a great work based on what I gave you. Now let's move to Mr. Ahmed in here. Now I need you to do the sodium. Sodium is Na. This is the symbol of it. It's 1123. The same way Mr. Hassan did, and Mr. Hassan and Moana, please pay attention. So first, start with the mass number. I'll write it down for you. So, what's the atomic mass number? No, don't do the configuration. Just give it to me like this. Atomic mass number?
20.
Excellent. Okay, I just need to delete what you've done in here. Oh. No, I've removed it. Fine, thank you. Now, what's the atomic number?
11.
Very good, the smaller number. And what's the number of protons?
11.
Very good. And the number of electrons?
11.
Excellent, because it's equal to the protons, and that's why the atom is neutral. Now let's see the neutron. Do you know how to do it?
12.
How did you know?
Very
good. So 23 minus 11 equals to 12 neutrons. So sodium has 12 neutrons. Now, as a summary of what we said, I'll repeat it again. In here, any matter consists of tiny particles known as an atom. This atom consists of subparticles known as protons, neutrons, and electrons. Protons and neutrons are found in the nucleus. That's why we call them nucleons. And their mass is the mass number. We call it the atomic mass number, as you see in here. The number of electrons, which are negative in charge, is equal to the number of protons, which are positive in charge. That's why the atom is neutral in charge. And the neutron, it says it has no effect on the charge of the atom because it has no charge, or it's neutral on charge. The electrons are revolving in orbits around the nucleus. These orbits, we call them shells. And as we know, each shell or each energy level is able to carry a certain number of electrons based on the rule we said, which is the number of electrons equals 2n to the power 2, and represents the level number. At the end of this lesson, you should be submitted with an assessment sheet to be done. Wish you all the best and have a good day. Thank you.